Welcome to the Gestalt IT Rundown for Wednesday, August the 30th. My name is Tom Hollingsworth, and I wish I was on a beach somewhere right now because it is National Beach Day, but I'm just here in my office with nobody distracting me today, like, I don't know, my co-host, Stephen Foskett. Hey, Stephen, welcome to the show.
Hey, Tom. It seems to be a theme today because not only is it National Beach Day, it's also National Toasted Marshmallow Day, which is actually an excellent thing to enjoy on the beach, unless you get sand in it, and International Whale Shark Day. Do you think the whale sharks know they have a day?
I don't think that they do, but I do think that the whale sharks enjoy a nice toasted marshmallow on the beach.
Maybe
Me,
a tourist with a nice toasted marshmallow in his hand. No, they're vegetarians, aren't they?
yeah, they probably are.
Yeah.
But we are not. We are consumers of all things great and wonderful when it comes to the news, and we have a lot of cool stuff coming up. It's been a busy week. We're going to start off with a great story from Google because they introduced new storage solutions for Google Cloud Platform during Next 2023 this week. It includes Google Cloud NetApp volumes for enterprise data migration, cloud storage Fuse for customizable file systems, and Parallel Store, a high-performance file system for AI and HPC workloads. These additions underscore the increasing focus on data storage in the public cloud, particularly for emerging applications like AI. Stephen, you're the storage guru. What's Google getting at here?
Well, Google's getting at some storage. That's what they're getting at here. And first off, pat on the back to Google. They've had some criticism in the past for their cloud not being as enterprisey as Azure and AWS, but boy, they have really stepped on the gas in the last couple of years. And GCP really has some fantastic features. One of the enterprise signatures, honestly, is not just high performance, but highly scalable, flexible, integrated storage. And that's what we're looking at here. So first off, NetApp, Google Cloud NetApp Volumes is the new name for the integrated native NetApp solution for storage in the cloud. Just like in AWS and Azure, NetApp is really probably has the best enterprise storage solution in Google Cloud. And boy, this is a nice advancement. So again, pat on the back for both of them. I guess NetApp actually was also named Google's Cloud's Partner of the Year or something like that. And you can kind of see why. I mean, basically, NetApp is delivering in the cloud what they deliver in the data center, and Google's eating that up. And so will their customers, I bet. The next thing is Fuse. Now, those of us in the Linux hacker universe have used Fuse for many years as a way to run all sorts of oddball file systems without having to install something in the kernel. Well, now Google Cloud Storage Fuse allows you to do a similar thing in Google Cloud. You can create a new file system that can be customized in various different ways. And this, again, allows Google to do more with storage. Then finally, I want to hit Parallel Store. Those of you who've watched Storage Field Day in the past have been, I'm sure you've noticed the Intel DAOS distributed asynchronous object storage platform. This thing is fantastic. It was one of the really, I think, overlooked things that Intel developed and delivered to the storage community. Unfortunately, with all the noise around NAND flash and Optane, a lot of people didn't notice what was going on with DAOS, but it's really great, high performance, open source distributed storage solution. Well, now Google's got Parallel Store, which is basically DAOS in the cloud. I'm very excited to see what this means for HPC and AI workloads. So in summary, Google's really done some nice stuff here. They've introduced some good storage solutions at Google Cloud Next. Tom, the long-awaited ARM IPO, which we've covered many times here on the Rundown, has been filed. We actually didn't cover this last week because we were busy with stories from VMware Explore, but SoftBank has filed the paperwork to take the company public. The company was purchased for $32 billion back in 2016, and there'd been a deal in place to sell the company to NVIDIA, but that fell apart. ARM sales were down a little bit in the second quarter, which could create some complications for the IPO. But what's your take on this final filing for the IPO?
Well, Stephen, we've all been sitting here shivering with anticipation.
Say it.
No, this is one of those things where we're like, okay, we knew this was coming. We really knew this was coming. When is it going to get here? So I'm going to preface this whole story by saying I am not a financial analyst. I have no fiduciary responsibility to you. So please don't listen to my advice when it comes to investing. That being said, I think that this is actually something that SoftBank really wishes they would have gotten out the door a little bit earlier for two reasons. One, those second quarter results do not bode well. Now, you're probably thinking to yourself, but ARM is everywhere. I've seen ARM being used in a lot of things. In fact, we have a couple of ARM stories coming up. I don't think the softening of demand was because people don't want to buy ARM chips. I think people stopped. They pulled back on their ARM purchases because they weren't sure what SoftBank was going to be doing with the company. I think that this was all created by not demand driven, but by the supply side, basically saying, I want to make, I need a little bit more information before I'm really ready to commit. The other thing that I think is interesting is right now, according to the analysts, they're looking at maybe around a $6 billion IPO, which is good. It's not what they paid for it. But I think that SoftBank is hoping that it will float up some of their other, their stake in the company, so that they can then go out and use that to fund more investment. Because, when they missed on WeWork and they had all of this money locked up in ARM and then couldn't get rid of it by selling it to NVIDIA, like they're basically stuck. And there's two things in the world. Banks don't want to keep their money unless they have to. And investment companies don't want to be stuck with investments that don't pay off. And that's where they're kind of sitting right now. So I feel like if SoftBank had gotten this out the door 3 months ago, that number would be a lot higher than $6 billion. And I think that they're kind of smarting from it a little bit. So now they've got to get it out so that they can use that to kind of refund some rounds to get some more investment in. We're obviously going to be keeping a really close eye on it. And it's funny how in a week we've gone from, oh yeah, IPO is going to be happening, to a lot of people who are now kind of sitting back going, I wonder how this is going to be happening. There's always that thing in finance where the longer you look at something, the less or the more things you find that you don't like. And I hope that doesn't create problems for ARM and SoftBank, because that's one of the things that ultimately sunk their deal with NVIDIA, is the longer people looked at this, the less sense it made. And I think that we're going to see people kind of rushing to get this done. Hey, Steven, is that an Apica over your shoulder? No, it's not, because it's Apica, the leader in synthetic monitoring and observability, because they've acquired LOGIC.AI and raised $10 million in funding to introduce active observability, which is a unique blend of synthetic monitoring and observability solutions. The approach addresses data challenges for IT, DevOps, and monitoring teams by offering comprehensive data pipeline control, a unified information view, and efficient high-quality storage, your favorite. This integration is set to enhance performance analysis and cut costs for enterprise customers, with LOGIC.AI's features being integrated into Apica's Ascent platform, and it's expected to launch in Q3 of this year, which is coming up pretty quickly. So, Stephen, what's your take on this acquisition?
For those of you who don't know, Apica is really the darling of Cloud Field Day. This is a company that has presented, and the delegates just loved it because, frankly, what Apica does is something that everybody in the operations space wants, which is basically keep your stuff running. And if it's not running, let you know. And if it's not running and they let you know, tell me what's wrong. What is the root cause? That's what Apica's Ascent platform does. Now, Apica has added to this platform by bringing in a data fabric in the form of LOGIC.AI. It's also raised a little bit of new funding. And the point here is that what they're trying to do is basically add to the existing platform in a logical way that gets its new capabilities and allows it to compete in this enterprise observability space. It really is a fantastic combined product. I can't wait to see what they're going to be doing with this, because it makes a lot of sense to take the kind of active observability that Apica is known for and bring in this larger world of observability and data pipelining. So we'll see what this means, but overall, a pat on the back for Apica, and also a pat on the back for doing this right without having to, mortgage the whole company here. You brought in a little funding, you brought in a new product, and you brought these things together, and you're going to deliver it to the market pretty quickly. Overall, nice job. Tom, a couple familiar names are in the news. Cisco and Nutanix have announced a global partnership for hybrid cloud customers. Cisco's UCS and Intersight platforms can now officially run on Nutanix's cloud platform and will be sold directly by Cisco. The solution is verified and fully integrated to provide users with the full support of both companies after deployment. Tom, what does this partner provide on both sides?
Well, it gives Cisco the opportunity to say they finally run Nutanix. And that's one of the things that a lot of people on the inside have been telling me is that normally if you buy UCS and you buy all this stuff, and then you start running Nutanix on it and you call for support, you usually get the shoulder shrug emoji when you ask them, hey, how does this work? For Nutanix, it gives them another avenue. And I'll remind you that it was so long ago, back in December of last year, we were talking about the fact that Nutanix might get acquired by HPE. That ended up not happening. And that basically means that with all of the GreenLake stuff that HPE has been doing, Nutanix really needed to find a good partnership to kind of get in front of more customers. And when you consider that Cisco UCS is kind of aimed at that hybrid cloud market, this is a really good partnership. For those of you who don't know, when Cisco signs a partnership like this, what they effectively mean is we're going to sell your stuff through our price list and provide support through our teams. And that is very appealing to companies that buy things from Cisco. The one finger to point model, which I think is the most polite way of putting that, means that if there is a VAR that has sold you the solution and something breaks on it, you only have to go to that one VAR, and that one VAR then now only has to go through one support solution to be able to figure all of this stuff out. And that's really what companies want. They don't want this hobby kit kind of solution where you have to call like 14 different places and go look up 3 different web forums in order to figure out how to make it work. They want it to work easily. They want it to be manageable from an easy perspective, and they want to be able to get support on it as quickly as possible. And that is valuable for people who are still using a hybrid cloud model, because even though we're using the C word here, we're not really using cloud. What we're doing is we're using cloud management in an on-premises solution. And I think that there's value still in that for Cisco, for those organizations that are not quite ready to move everything to the cloud, or better yet, the ones who have a regulatory reason not to move things to the cloud. And I think that that's still going to be a huge part of the business for both of these companies going forward. And with all of the stuff that's been going on in that market for a while, I think that this is ultimately a good partnership. Note that it's not an acquisition. That's definitely not what this is. This is simply 2 companies deciding that they have, a chocolate and peanut butter kind of solution, that they need to get together and do something that will allow them to make money all over the place. I think it's ultimately going to pay off in the long run. It's going to float Nutanix's profits up, which they really want. It's going to help Cisco sell more UCS and Intersight now, which, with cloud, that pathway hasn't been quite as clear as it has been in the past. And I think it's going to make some customers really happy, if nothing else, because now they can officially run the thing that they've probably been doing for the last few years anyway and get support on it. Stephen, IBM has unveiled the TS1170 tape drive, which features 50 terabyte cartridges, which surpasses LTO-9 capacity. They have 400 megabits per second of raw throughput, and it supports 150 terabytes compressed capacity, which is a 3-to-1 compression ratio. It is a proprietary tape format, but it outpaces LTO's capacity. This highlights IBM's dominance in the field of enterprise tape, which is something we've known for a very long time. Stephen, I know I'm going to pander to the audience here, but does this mean that tape isn't dead after all?
Tape isn't dead, Tom. Tape isn't dead. And surprisingly, tape lives at IBM. I don't know. Is that surprising? Well, it's true. Tape isn't dead. Tape makes a lot of sense, especially for archival data. And the dirty secret is that a lot of cloud providers, not to mention enterprises, of course, are using tape in various places in their infrastructure, even though they probably don't want to talk about it because tape's not that sexy. But this is actually kind of sexy and also kind of perplexing. So let's get this straight. So first off, this is not an LTO cartridge. So if you know at all about tape, you know about LTO. LTO is the universal standard, the generic universal standard for tape drives from all manufacturers. It might come as a surprise to you to learn that IBM manufactures most of the LTO tape drives. In fact, I'm not sure if anybody other than IBM manufactures them. But then it might come as a surprise that IBM has their own format of tapes. The artist originally called Jaguar, those of us who've been in the industry for a long, long time, remember when this thing was introduced, the 3592, was IBM's own format of tape. And I think at the time, a lot of us thought, hey, that's going to compete and IBM will focus on that and LTO can be the industry organization. Well, No, that's not what happened. IBM has continued to develop the 3592 format into this latest thing, and at the same time participate in the LTO world as well. And now we're at a position where the current generation of LTO tape format, the LTO 9, is offering 18 terabytes of native capacity on a cartridge that is very, very similar in size and shape to the IBM Jaguar format, and yet IBM has already passed the this limit here with the announcement of a 50 terabyte cartridge in the 1170. So basically, we've got IBM delivering not just LTO, but also its own format that is probably superior in many ways. But that being said, this is not like a problem for LTO. LTO is the industry standard, and it's probably what a lot of people are going to use. But if tape is going to maintain competitiveness with archival disk and archival flash, especially, it's going to have to offer greater and greater density. And that's just what we're seeing here. So, again, IBM's got 50 terabyte native capacity on these things. They've already suggested that they're going to have more than that, maybe 80 terabytes in the next release. There's also LTO in the development that's going to go, double and double and double again in LTO 10, 11, 12 in the future. We just don't know when those things are going to come. But I think one thing we do know is that they're probably, surprisingly, going to be delivered by IBM. Tom, the EU's Digital Services Act, or DSA, requires major tech platforms like Meta, TikTok, and Google to be more transparent and accountable. But these companies seem unprepared for enforcement, which begins now. The DSA aims to curb harmful content and enhance transparency in algorithm usage. Companies such as Facebook and TikTok have failed DSA's tests, raising questions about its effectiveness. The EU's approach to enforcement and the potential impact on tech regulations and user rights remains uncertain. And one thing I can say is there's some pretty hefty fines promised for this. What do you think about this?
6% of global turnover is definitely not something to sneeze at, and that's basically the same as what GDPR has been targeting for a while. Note that that's up to 6% of global turnover, so they capped it. If you think of GDPR as we're fixing privacy, DSA is basically we're fixing the platform. And when you get into the weeds of how it works, the first thing they want to do is they want to be able to remove harmful content. And that is less about me trying to steal your data and, things like spreading, false news stories or incorrect things. Like I saw something the other day where people were talking about drinking borax. And I'm like, that's harmful. People need to stop. And this DSA gives them the ability to go in and say, you need to remove all of these videos because they are causing a public harm. But more importantly, something that we've been worried about for years is how does the algorithm work? Because it feels like there's a lot of crazy things that are going on in there. And the DSA basically says you need to have your algorithm be more transparent to our investigators so we can figure out how these things work. And of course, everybody is freaking out because I'm sure they don't know how it works at this point. And they're trying to unwind all of this stuff. Now, there are people who are saying that this could lead to censorship. This could cause problems for smaller platforms. Although I will say that at least right now, it's only targeted at very large search engines and very large social media platforms in this initial phase so that they can kind of do like a smoke test to figure out if everything's going to work. And only then will it kind of roll down to the smaller platforms. But realistically speaking, I have to think to myself, if your platform isn't transparent enough that an investigator can come in and quickly unwind what's going on, what exactly are you trying to accomplish here? And the biggest worry that I have is that Facebook, Meta, is going to take the same route that they did with the law from the Canadians about paying people for news stories. They're just going to stop. They're going to pull out. Now, obviously, they can't do that because a lot of money comes from Europe, but they're going to have to find ways to mollify people. But ultimately, I think what needs to happen is that these kinds of rules need to be adopted by more organizations, not just the EU, because we've already seen situations where the EU has one specific set of rules for people, and then everybody else kind of plays by a different set. There was a news story that came out the other day. Basically, if you try to install Windows 11 on a machine and you pick the EU or World English as your installation base, it doesn't install a whole bunch of extra stuff that would violate EU rules but if you pick US English, it does. And I think that we can't have this fractured situation where the EU has, obviously, they do have a different set of rules, but everyone caters to that set of rules, but then it's a free for all for everybody else. So I would like to see more organizations, more world leaders adopt these kinds of guidelines to force companies like TikTok, Meta, and Twitter, X, whatever you want to call it this week, into the limelight and make them help the rest of the world understand what's going on. Because I think what's actually going to happen is, as this light gets shown on these things, you're going to find out that there was a lot more nefariousness going on under the surface than we at first realized. And it's really going to make people start asking the kinds of questions that force the owners of these platforms to really behave themselves. Stephen, it is Hot Chips 2023 this week, and we have a lot of news stories that have come out of it. Intel has unveiled the Sierra Forest and Granite Rapids Xeon processors targeting data centers. Sierra Forest is Intel's first E-core Xeon with 144 CPU cores, while Granite Rapids focuses on core performance. ARM has introduced Neoverse Compute Subsystem, aiding Neoverse N2 core integration. AMD has previewed the Siena Epyc processors for edge computing with up to 64 cores, notable power efficiency in a compact form, catering to the edge computing market's demands. So we're going to run down these stories in a little bit of a closer look. Let's start with the Intel story. We talked about Sierra Forest and Granite Rapids. Sierra Forest is built on Intel's 3-process node. Like we said, it's their first E-core Xeon for data centers. Granite Rapids employs all P-cores. Both chips do share the same platform, which supports up to 12 memory channels, introducing multiplexer combined ranks of DIMM memory. And then Sierra Forest boasts 144 CPU cores, as we mentioned. The Granite Rapids is focusing on core performance. And I think that this is really Intel's move into trying to gain market dominance in the data center once again. Stephen, what do you think about these new CPUs from Intel?
Yeah, this is the whole ball game for Intel, isn't it? Basically, Intel is planting flag here, saying Xeon is back, baby, and that's really what we're seeing with these processors. So let's talk a little bit about the differences here. First off, there are 2 Xeon platforms that are being talked about as the next generation Xeon platforms. This is important, but that being said, all of these platforms fit into Intel's strategy of chiplet-based computing, which means that we could see some mixing and matching. In fact, we probably will see some mixing and matching and a whole world of different processors that will come out of this. So let's start with Granite Rapids, because it's the easiest one to understand. Essentially, this is the next generation after Sapphire Rapids. It incorporates the latest Intel performance, high performance cores with multi-threading, all the new features, everything. This is the all singing, all dancing, big bad Intel Xeon that you're expecting. And it will include a lot of stuff. Now, this is sort of an early preview of Granite Rapids, though it is expected to be delivered in 2024. Essentially, it's got all the good stuff. The Redwood Cove P cores that are used in Granite Rapids have their lower latency. They have better branch prediction, prefection, memory encryption, all sorts of good stuff built into them. We expect the final processors to include a lot more I/O, PCIe 5, CXL2, or maybe 3 support, all sorts of stuff, and to be delivered on a chiplet-based architecture, which means that Intel will be able to basically develop chips that have the right number of cores and then the right number of supporting I/O components to meet the demands of the data center. Granite is going to take the place of for multi-CPU as well. We expect to see these things in data centers with up to 8 processors in NUMA nodes and that sort of thing. So really, when you hear Granite, think next generation Xeon. This is the thing I know. This is the thing I am using today, and this one's going to be bigger, badder, faster, etc. Now, Sierra Forest is a different animal entirely, and an interesting animal. First off, we expect to see a new server platform built around this called Birchstream. Sierra Forest, Birchstream, man, I want to live there. The reason that we've got all these, let's say, pleasant code names is because Sierra Forest is built around Intel's E-core, not the P-core. This is really cool. This is something that all of us who've been watching the industry have wanted to see. If you remember, a few years back, Intel introduced sort of a performance core, efficiency core kind of thing, which is very similar to what you're seeing on the ARM side. For example, Apple's M1 processors have performance cores and efficiency cores. So do a lot of smartphone processors. AMD took a little bit of a different direction with this, with their Zen 4 and 4C cores, in that the Bergamo, which is their sort of answer to the E-core, is more of a stripped down version of their performance core instead of a whole new core. Intel's E-cores, on the other hand, are much, much stripped down. They are very different from the P-cores. They, for example, don't support hyperthreading. So if you've got one core, you've got one thread running. They do now support some of the more advanced instructions that Intel is delivering. At least they will in the Sierra Forest generation. And a lot of us, when we saw Intel introduce these E-cores, which are physically more compact than the P-cores, we were like, man, it would be cool if Intel delivered a super duper Xeon with lots of those instead of, kind of having it all be on the performance side. That's Sierra Forest. Essentially, we're expecting to see as many as 144 cores per processor running on Sierra Forest in the first half or maybe a little later of next year. And essentially, this will give Intel bragging rights in terms of the number of physical processor cores per socket. It will also probably deliver quite a lot of performance because, of course, these things will be built on Intel's next process node. As I said, the wide expectation is that they're going to support most of the advanced instructions that Intel has introduced recently in terms of accelerators, and that these processors will really be up to date in terms of the I/O aspect as well. So again, PCIe 5 and CXL and things like that. Because, again, these are built on chiplet approach, and the chiplet approach means that you can have a supporting I/O chip that gives the processor a lot of capability here. So in summary, Intel is kind of going in two directions with the next generation Xeon. They've got Granite Rapids, which is the big, bad multi-processor, does everything with the P-cores. And then they've got Sierra Forest, which is kind of a different animal, a little bit more light and nimble and low power. And so it's going to be interesting to see how AMD reacts to this and how these things compete against the rise of ARM and, yes, RISC-V in the data center.
I will say, Stephen, that I think that the reason why Intel has decided to do this is thanks to the cloud and the fact that we're starting to see a lot of cloud management technology kind of filtering down into the on-prem data center. Because when you think about it, there's two ways that you want to run these things. You either want to run them flat out and feed it as much as you can to get all that number crunching going, or you want something that just kind of maintains things in the background and it runs those workloads that don't need to ramp really fast. But you would want that to be as efficient as possible in the amount of rack space that you have in a data center. And I think that those kinds of mentalities are starting to drive chip development, because when you think about making AWS instances, you can have the big honking ones, but you don't want to run them very long because they're expensive. Or if you have things that just need to exist out there and do stuff, I mean, you can make those relatively cheap. So companies that are looking to do that kind of cost allocation can buy a few of these Sierra Forest machines, and basically, because they can they have so many cores, they can effectively part them out from a time sharing perspective or a virtualization perspective, and really cost allocate them efficiently. And then if you need something that has to run really, really fast, hey, we've got the Granite Rapids machines over here that will do that for you. So I'm glad to see that someone at Intel has kind of woken up and said, we can't just keep building the biggest, strongest, fastest chips. We also have to address the part of the market that needs, I don't know, the Toyota Camry of servers. You mentioned ARM, Stephen, and they were also at Hot Chips, and they have showcased two sessions highlighting their Neoverse processor designs. In the first session, ARM introduced the Neoverse Compute Subsystem, a solution that enables customers to seamlessly integrate Neoverse N2 cores in their designs. What do you think this means for ARM in the data center?
Yeah, so as you said, the first session that we want to talk about is the CSS. And so essentially, how most companies use ARM cores is either they license the core IP and kind of develop their own, or they kind of just drop in an ARM processor and go with it. But a lot of systems are now looking at wanting to integrate a compute core along with other functions. And that's been pretty hard to do so far. The CSS approach is kind of interesting because essentially what what ARM is allowing customers to do is take these Neoverse N2 cores, which again is the ARM data center core, sort of their mainstream, does everything, high performance ARM core, and drop the IP, the design of that core, into the design of something else they're building. So as we talked about before with chiplets, the idea would be that basically you would be able to take a CPU chiplet and then another chiplet that does something else entirely and integrate them onto the same chip, the same processor. Well, this doesn't necessarily isn't necessarily an alternative to that, but it does allow companies that are not using chiplets to do a similar thing with ARM's Neoverse N2 cores. In other words, if you were designing, I don't know, let's say an advanced AI processor or something like that, and you needed a high performance CPU core, you could basically use CSS to take the design of that chip and just sort of plunk it right down into your EDA plan and design your chip around it, and then you have that produced for you. You deploy it in a processor. It's not necessarily a chiplet. It's just a Neoverse N2 core that's integrated with what you're doing. So again, it's just a more flexible way to use these ARM cores. I think it's extremely smart for ARM to be doing this because people want to be able to use these cores, but the market is turning to the extent that people want to be able to integrate other functions, accelerators, and so on, along with CPU cores, and this allows ARM to get in on that game. On the other hand, the Neoverse V2 is an interesting announcement, mainly because we already knew about it, because this is what's used in the new NVIDIA Grace offering. So essentially, the V2 is the next generation of ARM's HPC core. And so the Neoverse V1, we already saw that. It's already deployed out there in HPC machines. The V2 basically takes all of that stuff and turns it up by anywhere between 10 to 15%. It's a bit faster. It's got a bit more of this, a bit more of that. It's manufactured on a new process node. I don't want to say it's not exciting, but it's pretty much what you expected from the V2 and not a lot of what you didn't expect. And that's sort of what the market needed. So again, this is ARM's HPC core. NVIDIA is already using it very, very well, I might add, in the Grace chips, and ARM is making it available to other customers.
Yeah, I think ARM is going to really end up being the kind of the builder aspect of things with, what you talked about with CSS, being able to kind of plan these things out and figure out how I want to use them, as opposed to going to one of the other larger companies and they're like, okay, you can do this or you can do that. You can't do both and you can't mix and match. With ARM, it's like, no. You can work within this a little bit. When you need more on this side, you can do that. I think it ultimately gives people the kind of flexibility that they're going to want. And when you give them the flexibility, they start writing applications that can take advantage of that, which means you're not just going to see things programmed for x86 anymore. You're going to see workloads that are being programmed for ARM. We've already seen that transition start happening in the consumer space, thanks to companies like Apple embracing the ARM technology. And so I think that you're going to see that move into the data center. And as you do, I think more companies are going to start getting on board with that, because when they see the performance gains of writing the software to take advantage of those ARM cores, then people are going to be like, oh, cool, I need to do that now. And that will kind of shift the market. And of course, with the ARM IPO looming, maybe this will increase consumption of those chips aside from mobile phones and desktops. All right, Stephen, we had one more company who presented at Hot Chips. We talked about Intel, we talked about ARM, but now it's time for AMD. They provided a glimpse into the upcoming Siena family of Epyc processors that have been tailored for edge computing. These processors are designed to offer up to 64 cores and 6 memory channels, focusing on power efficiency in a smaller form factor. Siena is projected to have power consumption ranging from about 70 watts up to about 225 watts. That's a significant reduction compared to the other AMD silicon configurations. The specific Zen Core variant, which would be Zen 4 or Zen 4C, being utilized in Siena hasn't been confirmed yet, but the chips are expected to ship later this year, and they are targeted at edge computing market demands. Stephen, edge is something that's near and dear to your heart. What's AMD hoping to accomplish with this?
Well, so Bergamo is AMD's offering for basically maximum core density in typically in cloud data centers. In other words, the current offering has 128 cores or 256 threads per socket, and man, that is a lot of processing power. But it may be too much for a lot of applications. So Siena is basically a scaled down offering. Now, again, we don't have a lot of details, but I'm going to go out on a limb here and guess that these are probably the compact Zen 4C cores that you find in Bergamo. In other words, these guys, AMD stripped out some of the supporting functions. They trimmed the wafers and kind of crammed things in as much as they could. But these are still full Zen 4 cores with the full Zen 4 instruction set. And this allows people to basically run at almost full speed any application that'll run on Zen 4 in a more compact form factor. And that's really what this is all about. So I expect to see Siena gaining ground, as we said, in edge devices, meaning smaller compute devices that are going to be deployed in the telco, 5G, maybe at the premises and industrial IoT kind of locations. I also expect Siena to find some ground in embedded network devices. And I think this is something you might be interested in, Tom, because basically this is the latest and greatest x86 platform from AMD, and in a smaller, lower power form factor. I think that we could see this almost as a competitor for the famed Intel Xeon D, which is Intel's similar lower powered, more integrated, less cores, but still a Xeon and still supporting all that good stuff. I think that Siena is basically AMD's Xeon D, and I think that we're going to see it in storage, in networking, in security devices. What do you think, Tom?
I think you're right. And that was one of the things that Intel really hit on when they developed Xeon D, was realizing that appliances don't need a lot of compute power. In fact, they work better when they don't have a lot of compute power, because you never want stuff being offloaded to the CPU for that work to happen. It just slows everything down. That's why ASICs have been so big for so long. And AMD is going down the FPGA route with their Xilinx acquisition, and they're really heavily investing in DPUs to do some of that offload stuff. But I think that if you want to have a holistic solution in a system that runs AMD DPUs, you've got to have a processor that's matched to that. You don't need something that's power hungry and going to chew up a lot of space in the system. You just need something to be able to run the management plane. And I think that that's where Siena really fits in nicely. Is I need a watchdog, basically, like a substitute teacher. I'm just here to make sure that nothing bad happens. But other than that, just do your thing. And by creating a low power option, but still supporting all of the other, Zen 4 instruction sets, you're basically saying, we're not going to run these things flat out. We just need them to kind of run the system. And then you can start building these, boxes on top of an entire AMD IP, which means you don't have to go look for somebody else to provide that, because it wouldn't have made sense to stick a big Zen 4 into one of these machines. So people might have been like, well, okay, well, they're kind of compatible, so maybe I can go with a lower power Intel chip and use AMD for my DPUs and things like that. And that is a huge boon for edge computing devices, because when you want to start deploying those things to the edge to do edge compute, edge networking, and all that other stuff, you want them to be self-contained, rock solid, but you also want to have your development team be able to program to that chipset and have something that is consistent inside of that, so that you're not, oh, well, crap, we can't use that instruction because this doesn't support it. And what if it has to fail back here? So I'm happy to see that AMD has kind of gotten the memo that you don't just build bigger, faster, you build purpose-driven stuff for all kinds of places where you want your chips to be deployed.
So a couple more things that we saw at Hot Chips that I want to touch on briefly that were just pretty cool. As you know, I am a huge fan of the Cerebrus wafer scale architecture. We saw this at Tech Field Day. It really blew away everybody at an AI Field Day event. Well, Cerebrus is still trying to basically push this unique architecture with massive, massive chips, basically an entire wafer of AI-focused processors. And now they've come up with a massive supercomputer based on their wafer scale architecture too. This is not for everybody. In fact, it's not for many buddies, but I think that there were probably going to be some big buyers looking for the biggest, baddest AI supercomputer out there. And that's what Cerebras is talking about. We've also talked quite a lot about RISC-V, so it was fun to see Sci-5 out there talking about their performance RISC-V core. Not too much detail, but the P87 or P870, they did talk about it a bit, and it looks like we're going to get ourselves a nice high-performance RISC-V core from them. We also saw a company out there called Ventana talking about their Veyron RISC data center processor. Now, this is a 16-core RISC-V IP core. It's got basically kind of the features you would expect in a modern data center processor, but it uses RISC-V instead of ARM or x86. Be interesting to see where that goes. SK Hynix and Samsung were there talking about advanced memory technology that combines compute with memory. That's kind of cool. And Samsung's in particular piqued my interest because it's integrated with CXL as a compute and memory module combined. These are experimental, to say the least, but it shows the direction that companies in the memory space are going to integrate compute with memory. And then finally, I just got to talk about this. We talked a little bit about how Intel's E-cores are not hyper-threaded, their P-cores are. AMD has hyper-threading. There's hyper-threading, and then there's, hyper, super duper threading. Intel showed this crazy processor that has 8 cores. And you're like, yeah, so what, 8 cores? Well, it's got 66 threads per core. This thing was designed for a very, very particular use case, but it shows the kind of things that Intel is capable of. And yeah, that would be 528 threads on a single processor with silicon photonics. Again, this is not something you're going to buy. This is just plain cool.
Yeah, I would agree, Stephen. There's a lot of really cool technology out there. That's one of the reasons why we love, showcasing it to you on the rundown, because we can say in a couple of years when it really hits the mass market, we're like, we remember covering that on the rundown. And so we have some great stuff coming up that you're going to want to take advantage of, because Stephen, you're a very busy person in the coming weeks. What have you got coming up that people should be looking at?
So coming up soon, we've got Storage Field Day. We're going to be co-locating with our friends at Siena and their Storage Developer Conference, so that's going to be great. We just announced that Solidigm will be joining us on site there at Storage Field Day. We also have Edge Field Day coming up in October. Again, I'm a big fan of Edge, and looks like our friends from Dell are going to be there. And then finally, Cloud Field Day is coming up the same week as OCP Summit. So keep an eye out for that, as we've got some announcements coming about companies and delegates for Cloud Field Day.
And as always, you can always catch the rundown on Wednesday around 12:30 Eastern time. You can check us out on our website at gestaltit.com, where you'll see show notes, linked articles, things like that. You can subscribe to our YouTube channel at youtube.com/GestaltIT video. If you prefer to listen to us in podcast, of course, look for Gestalt IT Rundown in your favorite podcast application of choice. We love bringing you the news. We love seeing great stuff that you bring to our attention. Hey, we should totally check this out. So anytime you want to interact with us on social media, look for Gestalt IT, use the hashtag rundown. We love seeing your comments. We love hearing from people that get their news directly from the rundown. We had quite a few people who mentioned that at VMware Explorer last week, and it warms our hearts when we're your go-to source for news and maybe a little bit of fun commentary. We'll be back next week with another great episode. Until then, take care of yourself, stay cool, and we will see you soon.